Lesson 3C, Balanced Chemical Equations. Recall our last example of a chemical equation N2 plus H2 yielding NH3. We said that this was a skeleton equation. The number and the type of the atoms on the left-hand side of the equation did not equal the right-hand side of the equation. To illustrate this, let's draw the molecules of nitrogen, hydrogen, and nitrogen trihydride. Remember, we described the chemical reaction as where bonds are broken and atoms are reassembled and new bonds are created. So we break the bonds of the diatomic nitrogen and hydrogen, but as you can see, there's not enough hydrogen to make the NH3, and there's one too many nitrogens. So what happens to it? Well, the law of conservation of mass states that matter cannot be created from nothing, nor may it disappear into nothing. It may only change forms. From this law, we see that the reaction is impossible the way it is currently written. The number and type of atoms on the reactant side must equal the type and number of atoms on the product side. We solved this problem by using coefficients in front of each chemical formula. These are multipliers, just like math class. So here's our original skeleton equation. You can see that on the reactant side, we have 2 nitrogens and 2 hydrogens available for the reaction, and on the product side, NH3 has 1 nitrogen and 3 hydrogens. I will put a 2 in front of the NH3, which means the reaction will produce 2 NH3 molecules. The new total of nitrogens on the right-hand side is now 2, and the hydrogens become 6. As we can see, the 2 nitrogens from N2 are now accounted for, but we need 6 hydrogens to make the 2 NH3s. So let's put a 3 in front of H2, which means we have 6 hydrogen atoms available when the bonds break to reassemble into the 2 NH3s. That means we only need 1 2N2, and our equation is balanced. The type and number of atoms on the reactant side equals the type and number of atoms on the product side. If we go back to our drawing of the nitrogen and hydrogen molecules, we have 1 N2 and 3 H2s. The bonds will break, allowing for the atoms to rearrange. The atoms now will rearrange into a group of 1 nitrogen and 3 hydrogens. New bonds are created and we end with 2 NH3s. The final balanced equation looks like this. 1 N2 plus 3 H2s yields 2 NH3s. Here are some hints to help you balance equations. 1. Make a table and adjust the numbers of each atom as you work. Never change the chemical formulas. Do not change the subscripts. Only add coefficients. Do not break up the polyatomic ions if they're found on both sides of the formula. And save the pure elements to balance last. This includes the diatomics. And treat H2O as HOH. Let's try this reaction. CH4H10 plus O2 producing CO2 and H2O. Here's our table of atoms. 4 carbons, 10 hydrogens, 2 oxygens on our reactant side, and 1 carbon, 2 hydrogens, 3 oxygens on the product side. We will save O2 to balance last. Let's balance the hydrogens first by adding a 5 in front of the H2O. This makes 10 H's and 7 O's on the right-hand side. Next, balance carbon by placing a 4 in front of carbon dioxide. This makes 4 carbons and 13 oxygens on the product side. To balance the oxygens on the reactant side, I will use 6.5, which balances the oxygen at 13. This means the coefficient in front of C4H10 is 1. However, we generally want integers for our coefficients, which we can achieve by simply doubling all of our coefficients to 2, 13, 8, and 10. This changes our table values by a multiplier of 2 as well. As you can see, they still balance: 8 carbons, 20 hydrogens, 26 oxygens. At the top, we have our skeleton equation. On the bottom, we have our balanced chemical equation. Our last example is AgNO3 plus CuBr2 yielding AgBr plus Cu bracket NO3 bracket 2. Our table value shows 1 silver, 1 nitrate, 1 copper, 2 bromine on the reactant side, 1 silver, 2 nitrates, 1 copper, 1 bromine on the product side. I'll place a 2 in front of the AgNO3, and that changes our nitrates to 2, but also changes our silver to 2. To correct for this, we'll put a 2 in front of AgBr. That will change our Ag and Br on our product side to 2 each. Our equation is now balanced at 2, 1, 2, 1.